Imagine a medical student who scores 100% on every multiple choice exam. They've encyclopedic recall of every drug interaction and every rare pathology, but put on the wards and they freeze when a patient contradicts them. They can't prioritise a crashing patient over a stable one, and they can't navigate the messy bureaucratic reality of a hospital system. Would you hire them? Of course not. You'd say they have the knowledge but not the competence. And yet this is exactly where we are with health AI today. We have models that are technically superhuman at answering questions, but we don't know if they can actually be doctors. Today we're dissecting a timely editorial just published in the New England Journal's AI edition by Jack Gallifant and Danielle Bitterman. It's titled Humanity's Next Medical Exam, Preparing to Evaluate Superhuman Systems. When the machine knows more than we do, how do we know it's safe? Gallifant and Bitterman are responding to a shifting reality. They cite a recent study by Palapu et al. In 2025 where a Google-based system called AMI actually outperformed medical trainees in managing simulated breast cancer cases. The AI didn't just recall facts, it reasoned. The authors argue that we're moving away from the era of recall, where we just checked if the AI knew the answer, into the era of experience and agency. Their vision is very important. They want to stop testing AI like it's a search engine and start testing it like it's a medical resident. But here's the hurdle, and if you've worked in the NHS or any large health system, you know this one intimately. The gap between a multiple choice question and clinical reality is a canyon. As the authors point out, direct patient contact is only about 40% of a physician's shift. The rest is navigating bureaucracy, reviewing disorganized data, and making high-stakes decisions where there's no single right answer. Current evaluation frameworks are static, they're snapshots in time, but clinical medicine is a movie, it's dynamic, it's messy, and it evolves over time. The biggest obstacle isn't building a smarter model, it's that we literally lack the infrastructure to test how these models behave in the wild without putting patients at risk. We're trying to validate self-driving cars by giving them a written driving theory test. So what's the solution? Gallifant and Bitterman propose a new paradigm they called Humanity's Next Medical Exam, analogous to Humanity's Last Exam, which is a general AI benchmark that's seen as one of the toughest to pass. It's a comprehensive framework that they say is built on 3 pillars, and it's an excellent summary of where the field needs to go. So first is interactive interrogation. Think of this like a Viva or an oral boards exam. Instead of A, B, C or D, the AI has to hold a conversation. It has to defend its treatment plan, revise its opinion when new data arises, and handle a patient who might be confused or contradictory. It tests for adaptability, not just pure accuracy. Second, and arguably I think possibly the most important, are sandbox environments. This is the flight simulator for doctors. We need detailed virtual environments where an AI can act and observe consequences. The authors describe this as a virtual apprenticeship. The AI learns trade-offs like balancing the cost of a test against the risk of missing a diagnosis without harming a real human. And this aligns perfectly with a broader theme in AI development, which I felt was particularly well articulated earlier this week on the 20 VC podcast, where Jonathan Siddharth, the CEO of a data labeling company called Turing, described this exact necessity. I'll put a link to the episode in the caption, but he basically argued that as AI becomes more agentic, meaning it takes actions rather than just generating text, we have to build what he called reinforcement learning environments to provide models with positive and negative feedback on actions that it takes itself. It validates that healthcare isn't alone here. If you want an agent to act in the real world, you have to give it a gym to train in the first place. Smarter models need more complex data to train and improve them. We need to close the gap between the environment that models train in and the real-world deployments, data and tasks that they're likely to come up against. The third point was a real-world continuous learning. This is the holy grail, the learning health system. The idea is that the exam never ends. The system integrates the latest research and learns from every single patient interaction, pushing the boundaries of performance in real time. So now let's chart the path forward. How do we actually build this bridge? The authors rightly identified that technical advances aren't necessarily enough. We need an AI-ready health system. They call for strong government regulation to mandate open, standardized APIs to prevent vendor lock-in. We mustn't leave evaluation to the vendors themselves. We need a public, standardized sandbox layer in our health data infrastructure. If every AI company builds its own simulator, then they'll inevitably grade their own homework. We need a kind of version of the National Institute of Health and Care Excellence, or NICE, standard for simulation, not just for drugs. We need to fund the creation of these virtual patients as a public utility. Right now, the evidence for Superhuman AI is largely confined to these retrospective or chat-based studies. The proof that will turn skeptical clinicians into adopters isn't a higher score on the USMLE. The proof will be in seeing an AI navigate a sandbox simulation where it handles a rude consultant, a missing lab test result, and a patient with a complex social history, and handles it all smoothly and safely. Gallifant and Bitterman are right. We're entering the era of experience, and machines are ready to learn. The question is, are we ready to teach them?